melting glaciers, floods, and the threat of rising sea levels have been headline news in recent years. What's happening? The consensus among experts is that Earth's climate is changing due to the buildup of carbon dioxide and other greenhouse gases. To begin to understand what's happening, let's look up. The sky appears to go on forever. But viewed from space, you can see that the atmosphere is really only a thin layer of gases, mostly nitrogen and oxygen. Within this thin blue line, greenhouse gases keep heat that has reached Earth from radiating back into space. Without the greenhouse effect, our planet's surface would be almost entirely frozen. Carbon dioxide, or CO2, is a naturally occurring greenhouse gas. But human activities in recent years have led to an unnatural, immense buildup of atmospheric CO2. What is it doing? Let's take a look in slow motion. That molecule of carbon dioxide just blocked a wave of radiated heat from escaping into outer space. The massive amounts of CO2 that are emitted each year through the burning of fossil fuels are repeating this simple blocking action, and they are warming our world. There are other greenhouse gases: water vapor, methane, and nitrous oxide. What sets carbon dioxide apart from the other greenhouse gases is the astounding increase in CO2 levels every year for the past 150 years. Since the Industrial Revolution, we have been steadily burning more and more fossil fuels and emitting more and more carbon dioxide into the atmosphere. Fossil fuels are rich in carbon. The carbon in coal, petroleum, and gas was originally a key building block of plants. They drew in carbon from the atmosphere while converting light energy from sunlight into chemical energy, a process called photosynthesis. In prehistoric times, vegetation seasonally thrived, died, and decomposed in vast wetland areas. Under just the right circumstances and over long periods of time under intense pressure, these remains were transformed into fossil fuels, an extremely rich energy source. When burned, fossil fuels release their carbon, which binds with oxygen to form carbon dioxide, the greenhouse gas. Fossil fuels are our main source of energy today. This powerful and relatively inexpensive energy source is the driving force behind the technological advances in recent human history. But there are unintended consequences to this. By using fossil fuels, we release about 30 billion metric tons of carbon dioxide, as well as other greenhouse gases, into the atmosphere every year. The greenhouse effect, a natural process, has been pushed into overdrive. For the last 100 years, atmospheric CO2 levels have steadily increased. Like a dance partner, Earth's average temperature has moved alongside greenhouse gas levels. Every step isn't perfectly choreographed, but a variety of records tell us that overall, Earth's recent global warming has been driven by increasing amounts of CO2. In just the last 100 years, due to human activities, the Earth's average surface temperature has sharply increased by 3/4 degrees Celsius, or 1.4 degrees Fahrenheit, a rapid rise. Still, how can a temperature rise that's less than 1 degree be important? That 3/4 degree is actually an average. In that average, there are much larger temperature increases at the local level and wide shifts in climate patterns. The local temperatures in much of the Arctic have already risen by about 2 degrees Celsius, nearly 4 degrees Fahrenheit. Greenland is losing about 200 cubic kilometers, 50 cubic miles, of ice a year. In Europe, about 35,000 people died in the heat wave of 2003, and global warming may have played a role. The warming atmosphere holds more water vapor, driving more intense and destructive storms. Meanwhile, some inland regions have become deprived of rainfall, leading to longer and more frequent droughts. We can't precisely predict all the effects of climate change, but we can see that when climate change joins forces with other environmental changes, the consequences can be especially destructive. Increasing droughts may mean that established agricultural centers will have to shift to new locations at enormous economic and social cost. Drought always brings with it the threat of wildfires, which destroy plant life that would have naturally taken carbon dioxide out of the atmosphere. This loss is especially tragic as we already lose vast acres of carbon-absorbing trees each year through deforestation. The oceans are the greatest absorbers and storehouses of carbon. Atmospheric CO2 levels are increasing so quickly that ocean surface waters can't absorb CO2 fast enough to keep up. Excess amounts of CO2 increase acidity and may eventually distress life in the oceans. Further warming is inevitable. But if we continue with business as usual and do not reduce CO2 emissions worldwide, growing global populations, economies, and energy demands will push CO2 levels to new heights, where changes to Earth's climate would be vastly disruptive. But it doesn't have to be this way. Fighting climate change will require a combination of efforts. Conservation, efficiency, and clean energy sources can redirect CO2 down to livable levels. Efficiency goes way beyond changing a light bulb. Using natural light and following many other energy-efficient building practices reduces the number of times we need to switch on an appliance. We can choose to drive fuel-efficient cars, carpool, use public transportation, or even transport ourselves by bike or foot. There are many opportunities every day where we can make a choice to either waste or conserve energy. But individual actions can only go so far. When communities elect to fight climate change together, then it's possible to take big steps towards reducing CO2 levels. Public transit that's designed to link with other modes of transportation can allow us to get to most places without our cars. Countries that set policy that protect their forests ensure that CO2 is naturally cleaned from the atmosphere. Communities that choose renewable sources of electricity not only reduce CO2 emissions, but also ensure that they are not dependent on increasingly limited supplies of fossil fuels. In the future, we'll want to take even larger strides to develop new energy technologies that are in balance with Earth. It's going to take a big effort on the part of individuals, communities, and countries. Global warming will require global solutions. But each one of us can start right now, beginning with the next steps that you choose to take.